All right, well, here we go, guys and ladies. Dr. Krofchek here, in spirit and voice only. I'm not in school today, obviously, and you should be looking at the srcs7math.blogspot.com website to view today's lesson. And today's lesson is lesson 57 on page 400 in your book on negative exponents, scientific notation for small numbers. And I'm putting aside the way I would normally teach this to my chemistry students, and I'm going strictly by the book on how they do it. And I'm actually going through the book page by page with you on this one, so I make sure I teach it to you the book's way and not my way, which could be a problem. So, hey, listen, here's what we have to know. Here's the new concept. We're talking about negative exponents. First of all, what I want you to realize that when we're dealing with exponents, let's say we have something like 10 to the fifth divided by 10 to the third. The way we do these problems, division with exponents, is we keep our base the same. Our base doesn't change, so our base would be 10. And in division, we subtract the exponents. So 5 minus 3 would be 2, and that works out to be 10 to the second. Now listen, the way we prove that is we take 10 to the fifth is just 10 times 10 times 10 times 10 times 10, so it looks like this. 10 times 10 times 10 times 10 times 10, which gives us 1 with 5 zeros. And then we come back in and we put our comma in, and that's going to be over 10 to the third, right, which is 10 times 10 times 10, which is going to be a 1 with 3 zeros. Okay, and the way we can do this, guys, to prove that 10 to the fifth divided by 10 to the third is in fact 10 to the second, for every zero we have down here, we can cancel out a zero up here. And when we do that, we wind up with 100. And what do you think another way of writing 100 is? 10 to the second, right? Because 10 times 10 is 100. So this really proves what we're saying over here. This half of the paper proves this half of the paper right here. So that's why when we have 10 to the 5 divided by 10 to the 3, it's really like saying 10 to the 5 divided by 10 to the 3, and we subtract the exponents, the base stays the same. Okay, so kicking that dead horse a little bit, but that's how we do that. Now, with that in mind, that can present a bit of a problem. What do we do when we have something like this? 10 to the third divided by 10 to the third. Okay, well, we know that if we're subtracting the exponents, it should be 10 to the 0. So what's my answer? Is my answer 0? 10 to the 0 is 0? No. It might seem like that, but the answer to 10 to the 0 is actually 1. And here's the reason why. Let's look at this. When we have 10 to the third divided by 10 to the third, that's like saying we have 10 times 10 times 10, right? Hopefully you'd agree with that. And 10 to the third is 10 times 10 times 10. And now what we look at, guys, is that this 10, let me change my color here so you can stay with me. Oh, don't like what it's going to do here. This 10 and this 10 cancel out, and that becomes a 1. This 10 and this 10 cancel out, and it becomes a 1. This 10 and this 10 cancel out, and it becomes a 1, right? So we end up with 1 times 1 times 1 equals 1 over 1 times 1 times 1 equals 1, which that equals 1. So when we have 10 to the 0, because all the zeros canceled out, it equals 1. Hopefully that makes sense. So then if we have something like this, let me erase my board here. What if we have this situation? What if we have 10 to the second divided by 10 to the third? Well, we know that we're subtracting, once again, the exponents, so it really becomes 10 divided by, or 10 to the second divided by 10 to the third. Remember, our base stays the same, and we subtract 2 minus 3 becomes negative 1. That's what our answer actually becomes. It becomes 10 to the negative 1. And here's the way we show that. We have we have 10 to the second over 10 to the third. This equals 10 times 10 divided by 10 times 10 times 10. Now what happens is simply this. These 10s cancel out and become 1. These 10s cancel out and become 1, and we're left with the 10. So 1 times 1 is 1. 1 times 1 is 1 times 10 is 10, and we end up with 1 over 10 to the 1, which, well, 1 over 10 is actually equal to 1 over 10 to the 1. It's really the same thing. 1 over 10 is equal to 1 over 10 to the first power. Okay, so what we know then is when we bring all this together, what we should know is this, that 10 to the 0 equals 1, 10 to the negative 1 equals 1 over 10 to the first, and then 10 to the negative 2 equals 1 over 10 to the second. Okay, because 1 over 10 to the negative 1 is really going to be 1 over 10, and 1 over 10 to the negative 2 is 1/100th. So we have 1/10th and 1/100th. That's how that works out. So hopefully that makes sense to you. And assuming it does, let me go on to example 1, which is to, and this is in your book on page 401, which is to simplify these few problems. It wants us to look at 2 to the 0, 3 to the negative 2, and 10 to the negative 3. So how will we do that? Once again, you should know that 2 to the 0 power, anytime it's a power of 0, the answer is going to be 1. So anytime you have 2 to a power of 0, the answer is going to be 1. So 2 to the 0 equals 1. 3 to the negative 2, remember, it's going to be the same thing as 1 over 3 to the negative 2, okay, or to the 2 rather, positive 2, which is going to become 1 over 9. So 3 to the negative 2 is 1 over 9. Whenever we have a negative exponent, the numerator is going to be 1. So for 10 to the negative 3, it's going to be 1 over 10 to the 3, which is equal to 1 over 1,000. I hope that makes sense. Or in decimal form, obviously, it would be, it would be 0.001. Because 1/1000th is the same thing as saying 0.001. Remember, tenth, hundredths, thousandths place. So hopefully that makes sense for you. All right. Next, what we want to do is look at scientific notation, and for that our problem is this. We have 4.63 times 10 to the negative 8, and it wants us to put that problem into standard notation. To do that, we have to move this decimal place 8 places to the left. Because we have a negative 8, it's telling us that we have to go 8 places to the left. And so when I do that, I'm going to wind up with 7 zeros in front of my 4, because one of my places is right here at the point 4. Then I have to go over this many more places. As a matter of fact, if I put this down here, 4.63 times 10 to the negative 8, and I go out 8 places, then I'm going to have 1, 2, I got to put a 0, 3, 4, 5, oops, hang on, 5, 6, 7, 8. So I'm going to wind up with 0, I always put a 0 there, 0.000000463. And then I lose, when I move everything over, I lose my times sign my base of 10, and my negative exponent, and this becomes my answer. So if I want to go back to scientific notation and take this decimal back to where it belongs, it's going to go 1 place, 2 place, 3 place, 4 place, 5 place, 6 place, 7 places, 8 places, 8 spots to get over here, and that's how I get 4.63 times 10 to the negative 8, because it took me 8 spots to go this direction. Remember, when I move the decimal to the right, I'm going to make that exponent a negative number because I have to go back to the negative to get it back to its original place. That might be a little bit confusing. If it is, your tutor can work with you a little bit on that to hopefully make some sense of that for you. Let's go into our next example here, and now we have this big long problem. This one is 0. 1, 2, 3, 4, 5. Looks like there's 5 zeros there. 1, 2, 3, 4, 5 zeros, and then 3, 3. And it wants us to put this in scientific notation. To put that in scientific notation, remember, by the way, scientific notation has to have this. It has to have a number that is greater than 1 and less than 10. So it has to have a number that is greater than 1 and less than 10. And we're going to show that with the decimal point. So it's going to be a number greater than 1. So we're going to make it look like 1 times 10. It's going to have a base of 10, and it's going to have an exponent. It's going to have some exponent here we'll call x. So it's got to have a number that is greater than 1 and less than 10. So we can if we had 11 here, it would be 1.1, okay? A number that's greater than 1 and less than 10. We have our base of 10 and we have our exponent. That's how scientific notation is supposed to look. You can see that this right here does not look like that, so it's not in scientific notation. This is called standard notation. That's how it's normally or standardly written. To put it in a scientific notation, what we have to do is make this number fit into the scientific notation format. So this number's got to be greater than 1, less than 10. It has to have a base and an exponent. So let's do that. How many places do we have to move this decimal place over to get it to be in between a number that is greater than 1 and less than 10? We have to move it over 1 spot, 2 spots, 3, 4, 5, 6 spots. So that's going to become 3.3, and we moved it 6 spots, so it's times the base of 10 to the negative 6. Because to get it back to its original spot, we have to go to the negative part of a number line to the left, and that would get us back to our original spot if we wanted to see the number with all the zeros in a really long number. This is the way we shorten the number. It's called scientific notation, and that's how we would do that. And that leads us to our last problem for today's lesson. And in this problem, it wants us to compare 0 with 1 times 10 to the negative 3. So if I'm going to do this, I want to write 0 out as a number, and it's just like that, obviously. I want to compare it to 1 times 10 to the negative 3. How do I put 1 times 10 to the negative 3 in scientific notation? Well, I'm going to have 1, and my decimal place is right there. I have to go to the left 3 places, so I'm going to go 1, 2, add a 0, 3, add a 0. I'm going to wind up with 0.001. And from a chemistry point of view, we always put a 0 to the left of our decimal. So now I'm comparing 0 with 0.001. Which number is larger? Well, even though this number is very small, because there's a 1 in it, it's going to be bigger than 0. So 0 is less than 0.001, or 0 is less than 1 times 10 to the negative 3. Okay, I hope you understand that. I'm going to leave all the explanations for your tutor to go over this with you if they feel so inclined. If not, you can start your practice set, which today, by the way, is going to be practice set A through M, and then of course that's your practice set that's due for tomorrow. or actually do on Monday. And then your written practice. Your written practice is, as always, 1 through 30 all, and that's going to be found on page 403 through 405. All right, hope you have a great Friday. I'm not going to be in school, obviously, today, so I'm taking the day off, enjoying myself. Have a great weekend, and I'll see you on Monday.